They finally did it! Intel moved off of their 14nm process node, redesigned their cores, and even added a whole other CPU for good measure. This is such a significant moment for Intel, and actually for the industry in general, so you can expect this video to be a tad on the long side. And there will be countless follow-up videos testing everything that I can think of, including the i5 that I wasn't able to test for this video. That will be coming up very soon in the coming days, so make sure you're subscribed with notifications on because you don't want to miss any of this. This is the i9-12900K. Intel's first mainstream chip built on the Intel 7 process node, the one that used to be called 10nm Enhanced Superfin, but was renamed to both differentiate between their other 10nm nodes and to align more with TSMC and Samsung's 7nm nodes, despite them being quite different. A shrink in the process node generally means more transistors and less power consumption. So naturally, Intel's approach is to shove essentially a whole other CPU in there. That's essentially what the hybrid design is. You get two CPUs for the price of one. Okay, technically it's like, 25% more than the price of one, but it's not double. What you get is actually nicely displayed on this rather nice and very shiny plaque they sent to us reviewers in the press kits. So let me show you on here. These large blocks in the middle, those are the performance cores, or P-cores as they call them. These are much like the cores found in the 11900K, although they have been redesigned with a fair few changes. If you want to know more about those changes, the ECores, and the whole hybrid design in general, then do check out the video in the cards up above if you haven't already. So that bit is pretty normal, right? But now look down here. See these blocks of 4 in a sort of small cluster? Well, those are the efficiency cores, or E-cores. These don't support things like hyperthreading. They run at lower clock speeds, but are designed to be, well, efficient, as the name suggests. So with all of these new cores, unsurprisingly, there's a new socket that these fit into. The chips are actually now rectangular and have 1700 pads on the back, up from 1200 on the last gen. That means a new chipset too, called Z690, and I'll have a video on those boards soon as well, but it's safe to say that there is a lot of new features. The biggest of which, or the biggest change, is to support DDR5 RAM, the newest iteration of memory, which as always runs at higher frequencies, but slower latencies or slower timings. And also costs an arm and a leg to get your hands on. Interestingly, Alder Lake CPUs actually support both DDR4 and DDR5 fully. So you'll be able to find Z690 motherboards that support DDR4 or DDR5. Just to make it clear, you cannot run both DDR4 and 5 at the same time in the same board, or even try and put the wrong type in either slot. The slots are physically different, so DDR4 won't fit in a DDR5 slot, and vice versa. You also get support for PCI Gen 5. No, we only just got Gen 4 and we're already on to 5, but I'd actually hold your horses there, because most motherboards, including this premium Z690 Hero I've got from Asus, only supports PCI Gen 5 to the top X16 PCIe slot. None of the M.2 slots supported, none of the other PCIe slots do either, just the top one. And it's also worth pointing out that Gen 4 is already somewhat pointless for the vast majority of people for both GPUs and storage, so these technically supporting Gen 5, I wouldn't call that a big selling point, and I would expect that by the time it is a selling point, these CPUs will be irrelevant anyway. Let me give you a quick, spec rundown on this i9. It has 8 P-cores, which can boost up to 5.2 GHz, and 2 clusters of 4 ECores that can hit up to 3.9 GHz, making for 24 total threads. It has 14 megabytes of L2 cache and 30 megabytes of L3, DDR5 4800 or DDR4 3200 RAM supports, officially anyway. Faster works just fine, but it's still considered technically overclocking, and a 125 watts base processor power, and a new spec called maximum turbo power, which is set to 241 watts. All of these new features, the hybrid cores, the new architecture, the new version of Windows you really do want to use with these, all of that adds complexity, and with complexity comes bugs. Lots of them. Issues with Windows 11 randomly tanking performance, BIOS issues like I've had, which can mean that you can't use XMP or even just set memory timings and frequency without reducing performance. And if you do use Windows 10, get ready to find some random apps that will get locked to the eCores unless you use Task Manager or a tool like Project Lasso to set the process priority to be higher, to then allow the scheduler to schedule tasks to all of the cores, including P-cores. Yeah, I would take all of the results that you see today with a pinch of salt, because I can almost guarantee that in a month's time, they're probably going to be wildly different. With that said, I actually found that I had the most consistent results in Windows 10, so that's what most of my results and tests that you'll see are based on. So, how does it perform? Well, in short, it's a beast. The new core design means that in Cinebench R23, this new 12900K is 23% faster in single-threaded work than both the last-gen i9-12900K and AMD's Ryzen 5900X. That is a significant leap, and one that translates to all-core workloads, as both thanks to that and the extra 8 eCores, this offers 93% more performance over the 11900K, or about 27.5% more than the 5900X. That is incredible. Almost double the multi-threaded performance over the last gen. While I don't have a 5950X to test against, looking at publicly available results, it seems like the 12900K would pretty much tie in all-core workloads. The story is the same in the BMW scene in Blender. It's almost exactly twice as fast as the 11900K, or about 25% faster than the 5900X, and in the Adobe suites, it just runs away with it. In Premiere, it scores just shy of 1,000 points, 960 specifically, and the closest to that is the 5900X at 874, or almost 100 points less. And the last gen i9, well, that's the slowest, even being beaten by the 10th gen i9 because that one has 2 more cores. In After Effects, there's no question which is the fastest. The new chip is 13% faster than anything else, and it's the same story in Photoshop, where it's 19% better than the 1100K and 17% over the 5900X. But you're not here for productivity numbers, you want to see gaming. So let's take a look. Testing at 1080p with an RTX 3080, generally speaking, the new i9 comes out on top. Watch Dogs Legion shows the biggest lead, running 22% faster than the 5900X when run at medium settings. The last gen i9 matches the 5900X, with only the 10th gen i9 running ever so slightly slower. Cyberpunk also shows a healthy lead on medium settings, running 144 FPS average versus around 120 FPS for the rest of the pack, or about 20% faster. And a sizable improvement in the 1% low figures too, going from around 70 FPS on most of the other chips to more like 95 on the new i9. Some games weren't all that bothered, like Fortnite at high settings, which, while the 12900K is technically at the top of this chart, its lead is just 3%. And at 260 to 270 FPS, I would call that a paper victory for sure. Some games actually preferred Ryzen, like CSGO, where again it's very much a paper victory, but it is worth noting actually the improvement from 11th to 12th gen here, which is around 27%, and that's nothing to turn your nose up at. And then there's Microsoft Flight. For some reason, the 5900X comes out on top here, with an 18% lead over the Intel chips. This is something that I verified and actually was happening on both Windows 10 and Windows 11. Now I did also test at 1440p, but as you would expect, any differences that were present at 1080p are kind of smoothed out by the GPU taking a bit more of the load, and so while I will include those results in the written article, I'll leave them out here. One of the interesting things is that in the BIOS, you can actually disable some or all of the ECores, meaning that you can see the performance offered exclusively by the performance cores. So of course I did just that. Comparing to the 11900K, the P-cores are still 23% faster in Cinebench R20 single-threaded. That is still a significant advantage, and again that carries over to the multi-threaded workload, where the P-cores in the 12900K were actually 40% faster than the last gen 1100K. A 40% all-core improvement would already be an incredible thing to see, an incredible upgrade, but then when you add the E-cores, well, that's just crazy. Interestingly, in the Adobe suite, the P-cores on their own score lower in Premiere than with all of the cores enabled, which kind of makes sense, right? I mean, there's less cores, meaning rendering, playing back footage, that sort of stuff has just less to work with. Although I should still add that it's still 14% better than the 11900K. But what really surprised me was the After Effects and Photoshop scores. In After Effects, the 12900K improved its score by 3%, assumedly because the P-cores had more power budget to work with and could turbo harder for longer. And the same happened in Photoshop, with a 3.6% higher score with the E-cores disabled. In gaming, CSGO saw a significant improvement of 7%, meaning it outperformed the Ryzen chip, the reigning champion, and Cyberpunk also saw an improvement, not by as much, but still extending the lead over the rest of the pack by a further 5 FPS. And in Microsoft Flight, well, that also saw a fairly significant rise, bringing it to almost the same as the 5900X. Watch Dogs saw a slight uptick, only by 3 FPS, and Fortnite, it just didn't notice, offering the same performance as stock. While you are able to disable all of the E-cores, you can't disable all of the P-cores. At least one needs to stay running constantly, regardless of how many E-cores are active. That would be a problem if you wanted to measure exclusively the performance from those E-cores, if not for Windows Process Affinity. In Task Manager, you can select which cores a process is allowed to use. So for every benchmark, I disabled Core 0, the one remaining P-core, from being used by the program or game. And the results? It's a 10400F! No, seriously, all 8 E-cores offer roughly the same performance as an i5 10400F does. In Cinebench R20, the 10400F only runs about 6% faster single-threaded, or about 8% faster all-core, which is remarkable considering these are just some extra cores tacked onto the side of an i9. Unfortunately, the E-cores actually draw more power than the 10400F, or about 80 watts at stable sort of power usage, or a peak of 95.5, whereas the 10400F, at least in my previous testing, drew more like 75. What's interesting is the gaming performance though. CSGO tanked compared to the P-cores, netting 366 FPS average versus the P-cores on their own, which netted 641. Cyberpunk also dropped pretty hard from 149 on the P-cores to 99 on the E-cores. Of course, still perfectly playable, but shows the performance delta well. Microsoft Flight also took a bit of a hit, although not by as much, 136 FPS to 122 or 121, so not so bad. And Fortnite also dips, going from 273 average to 202, which again isn't bad and it's certainly still playable. There is a catch though to this mental performance, and that's mental power consumption. Intel's new trick with this generation is the new spec I mentioned earlier of maximum turbo power. Instead of listing two different power level values, PL1 and PL2, where PL1 is the long-term power and PL2 is the short, much higher boost power, these new chips just run at PL2 constantly. That means that the 12900K runs endlessly at 241 watts and will never drop down unless it's thermally or electrically throttling. To put that in context, AMD's Ryzen 5900X and by extension 5950X are capped at 142 watts of total socket power as standard. So as stock, the 12900K will draw 70% more power than the 5900 or 5950X. Unsurprisingly, running 241 watts through now absolutely tiny chips isn't great for thermals. And in my testing, and confirmed by HardwareUnboxed and Dr. Cuttress from Anantech, this thing pings almost immediately to 100 degrees Celsius regardless of what cooler you've got on it, although every PR person I've spoken to has recommended at least a 360mm AIO or higher for this chip. It pretty much sits at 100 degrees Celsius until it's finished and then eventually comes back down. Again, for comparison, with the same cooler, even last gen's i9, which was generally regarded as a towering inferno, that peaked at 88 degrees Celsius at most, and the 5900X, well, that peaked at just 71 degrees Celsius and sat at a more stable 62. Taking a closer look at the hardware info logs, you'll notice that the CPU package temperature reading doesn't match the average core temperature reading. And taking a closer look at the core temperatures themselves, well, you can see why. 3 or 4 of the P-cores, the ones that happen to be in the middle of the chip, well, those are the ones that are running at around 100 degrees Celsius. But the ones at the top and the 8 E-cores at the bottom, well, they're a fair bit lower. The E-cores are all at 83 degrees Celsius, and the upper P-cores are in the low 90s. That, I suspect, is actually another advantage that Ryzen has. Having their cores split into 2 physical chunks of silicon under the IHS means that they're not concentrating heat into one large block, and so they can be cooled, well, more effectively. There are also a few other issues with this new platform. Resizable bar support, for example, is, well, technically available. Intel recommends disabling it until they can improve their firmware and for future product updates. That generally means that any gains that you've seen from enabling it or AMD's Smart Access memory are likely lost, at least for now. But it's not all bad news. On certain motherboards, specifically Asus, Gigabyte and ASRock, you'll find a sneaky little BIOS option. If you disable all of the E-cores, you'll find an option to enable AVX 512 support. I expect Anantech's review will actually include a lot more about this, as I played host to a remote benchmarking session which verified not only that this works just fine, but that it's actually faster than last gen and includes the new Sapphire Rapids instructions as well. Make sure to give Ian's article a read for more about that. Now, I think this video is already long enough, so let's start wrapping things up. All in all, the P-cores on their own showed excellent performance. They are a healthy improvement over last gen, while drawing slightly less power at peak, although technically more since the 11900K drops off a boost, whereas this thing doesn't. But the IPC improvement alone should be enough to see generally stronger performance in most titles. Some won't care, but some will a fair bit. So if that was them on their own, I would call that a welcomed improvement. But when you add the ECores, well, that's where it gets interesting. Once you get past the hiccups and bugs of an entirely new platform, new OS and scheduler, and a new paradigm in general, you get an impressive chip. I mean, it keeps up with a true 16-core Ryzen, despite being an 8P plus 8E design, so that's impressive, but I would also be lying if I said I wasn't at least a little bit confused. Intel calls these their efficiency cores, right? And yet they're drawing about 10 watts each under load. Sure, that's down from about 28 watts in the P cores, but my napkin math says that Ryzen's full fat cores, the ones in the 5950X anyway, well, they're drawing about 8 watts per core, and even in the 12-core 5900X, it's still only about 10 watts per core, and Apple's new M1 Max, well, that offers 30% more performance than these E-cores, but at peak, only draws 60 watts or 6 watts per core while delivering more performance. Sure, the E-cores are more efficient than the P-cores, but that's like saying a new 5-litre V8 Mustang gets good fuel economy just because you're comparing it to a new Capo Camaro with a 9.4-litre V8. Especially when we could all be driving around in Koenigsegg Chimeras, which are way more efficient and faster and actually even more practical. To me, this sort of hybrid big little design works really well in phones and mobile devices, stuff with batteries, because it makes sense, right? Use smaller, low power cores for the basic stuff and have some high power muscle on standby for when you need it. Saves battery, saves heat output. Cool. But in a desktop, or even a high power laptop, it just doesn't make that much sense to me, especially when AMD can do so much more with so much less power, actually less than even these efficiency cores can do. To top it all off, while the pricing for the chips themselves is actually pretty competitive, the i9 is currently on pre-order for around £600 here in the UK, where the 5950X is generally more like 700, the 5900X is around 480, as is the last gen i9, but once you realise that you'll need a new Z690 motherboard, which seemed to start at around £200, and for one that will handle this i9 with any level of dignity, you're probably more in the £300 range at least. Well, then you also look at the eye-watering price of DDR5, which for this Corsair Vengeance 32GB 5200 kit is a cool £300 right now, and a fat 360mm cooler that you will need if you want to run this chip. And for the fancy new Corsair one that I've been using, that's an insane £250, or even a more reasonable one from Arctic, like the Liquid Freezer I reviewed recently, that's more like 110. Well, add all that up and you realise that the cost of entry is a lot higher than it seems. Since a 5950X will run perfectly fine on a £125 to £150 B550 board, it can use £130 worth of DDR4 instead, and can even use a fairly basic air tower if you're desperate, or a nice £70 240mm AIO from Arctic instead. Well, suddenly the Ryzen option is now between £300 and £500 cheaper, and you'll have lower energy bills. I mean, admittedly, you won't have a space heater for the winter, but hey, maybe you can spend the extra on a higher-end GPU and make up the difference in both gaming performance and in heat output, well, that way instead. To make it clear, If you buy any of these Alder Lake chips, the i9 or not, at launch, you will probably be a beta tester. Windows 11 updates for the scheduler especially will be rolling out pretty much non-stop, I would guess, for a good 6 months before it calms down. BIOS updates will likely come thick and fast too. Features will break and you will find bugs and you'll just have to deal with them, so be warned. To answer the question in the title, I'm honestly not sure. I think for mobile and ultra mobile, designs, this, design itself could work well. Maybe in a generation or two, but for desktops, I'm not sure that it makes all that much sense. It adds a lot of complexity to solve a problem I feel like AMD has already solved, which is just making the cores more efficient. If AMD added 2 ultra low power cores to their chips, I could maybe understand it as a way to offload background tasks to crazy low power cores, leaving more power and thermal budget for the main cores to chew through. But even then, on desktop, I would still argue they should probably just head back to the drawing board. But with that said, those are my thoughts and the results and testing. I would love to hear yours in the comments down below. I'm going to be genuinely excited to hear what you think about this, see the performance, see the issues with the platform as they currently stand, and I would love to know your thoughts on whether this hybrid design is what you think is the future of computing, or do you think that better optimization like AMD has clearly done is a more sensible route instead? I would love to hear your thoughts in those comments down below. Of course, as always, I'll be leaving links to all of this stuff in the description. Those will be Amazon affiliate links. You may or may not be able to buy at least the new stuff just yet there, but I'll leave the links for you anyway. There are also global links that will take you to a local Amazon store where you can see things like pricing when and where you watch this, because it can and definitely will vary, especially depending on stock, so feel free to take a look. And there'll also be a load of other links in the description you can check out too. If you want to support the insane number of hours that I've been putting into testing this, especially because I got these samples incredibly late compared to everyone else, then feel free to support me directly through the YouTube join button, where you get access to our Money Min Discord chat, sponsor-free videos, and some cool emojis to use in the comments and on our weekly live streams, or you could do so on Patreon instead if you prefer. You can also pick up a hoodie or t-shirt like this one. These are ones that I designed myself, so feel free to take a look. Or there are less direct ways if you're buying from places like Amazon or Overclocked UK. There are affiliate links in the description that you can check out. There's also other services, things like VPN options, Humble Bundle, Streamlabs OBS, and a whole load of other stuff, so do feel free to check it out. Also, like I said, do make sure you hit that subscribe button and turn on the bell notification icon, because I cannot explain just how many things that I want to test, verify, and just talk about with this new stuff, so do stay tuned. And I'll leave some more videos on the end cards, probably the Alder Lake Explained video that talks a lot more about the hybrid design, so feel free to take a look at that. Otherwise, thank you for watching. If you have any questions, leave those in the comments down below. We'll see you on the next video.